Hello everybody, welcome back. So in our last video we explored the idea of an arithmetic sequence and series, and arithmetic just meant when you're adding a certain number from term to term, and that number was called the difference. But now what if you're actually going to be multiplying the same number from term to term? Then we have something that's called a geometric sequence. Geometric, you're multiplying the same number from term to term. When it was arithmetic, you were adding what was called the difference. And here in geometric, the number that you're multiplying is called the ratio. So we'll often use the letter R to represent that. So welcome to section 10.3. This is all about geometric sequences and series. So if you look, for example, here, the one I wrote out, here's a sequence. If you look and see, what am I doing from term to term? Well, here it looks like I might be adding 2 or multiplying by 3. But then if I go further, I'm adding 6 or multiplying by 3, and so on and so on. It looks like I'm multiplying by 3. So the number I'm multiplying each time is 3, so my R, or ratio, equals 3. How about this one here? Do you notice that this one is also geometric? Because what am I doing from term to term? Notice that's getting smaller in size in a way. If you ignore the negatives for a second, it's almost like to go from 64 to 32, I'm halving it. And then from 32 to 16, I'm halving. And then 16 to 8, I'm halving. I'm dividing by 2, but remember, this has to be what I'm multiplying by. Remember when we said the difference is what you're adding? So even if it's a negative number, if it looks like you're subtracting, you have to write the number that you are adding. So that could be a negative. Here, if I'm dividing by 2, I have to write what I'm actually multiplying by. So I'm dividing by 2, yes, but I'm actually multiplying by 1/2. But then you notice I am changing signs every other term, which means I'm actually multiplying by a negative also. So my official ratio, what am I multiplying from term to term, is -1/2. So both these would be considered geometric because we're multiplying to get each new number. All right, now that we know that, we're just going to play the same games that we played last time in arithmetic land, but now it's geometric. So again, in arithmetic land, we had a formula to help you find any number, any term you wanted in the arithmetic sequence. That was your a sub n term. This one now we have for geometric, so it's going to look a little different, especially because now in geometric we have more multiplying going on, and we also have an R ratio. So you'll see in this formula here, we have more multiplication going on, and we have R ratio. All right, friends, so here's your magic formula. If you want to find any term that you want in a geometric sequence, a subscript n, or a sub n, and n again is the subscript that tells you what place it is in the sequence, whether it's the first term, a sub 1, or the second term, a sub 2. You take the first term, a sub 1, and you multiply by r raised to the n minus 1 power. So it's almost like you take your first term and you multiply by r n minus 1 times. So there's your formula. A sub n for a geometric sequence is a1 times r to the n minus 1. All right, just to keep this back in your brain. When we were dealing with arithmetic, do you remember that formula off the top of your head? I'll write it here just to help you remember. That was a sub n equals the first term also, but plus n minus 1 times d, and d was that difference that we added from term to term. So you kind of notice how similar these two are. In arithmetic land, because I'm adding, this formula has addition. In geometric, because I'm multiplying, there's multiplication. Instead of having a d difference over here, I have an r ratio. But then you notice I still have the same n minus 1 in both formulas. So they're very, very similar, actually. All right, let's play. And here's how we're going to play. Just like before, can you find for me the formula for the nth term? Just meaning, can you find the a sub n formula or function of this sequence here? Now, I do say it's geometric, but can you tell why? What's my ratio that I'm doing from term to term? And again, it looks like I'm dividing by 2, but my ratio isn't 2, it's what you're multiplying by. So here, it looks like I'm actually multiplying by a positive 1/2. All right, I need my a sub n formula for this. So up above, we learned that a sub n is a sub 1, the first term, times my ratio, raised to the n minus 1 power. Let's try it for this one. All right, how about a sub n equals a sub 1 is your first term. That would be 8 times your ratio, which we said was here, is 1/2, and raised to the n minus 1 power. And remember, when we're doing the formula for the nth term, we leave the n in your answer, so that if I want to find the 50th term, I plug 50 in for n in both places, and I can find it pretty easily. All right, there's number 1. We found the formula for the nth term just using our new geometric sequence formula. All right, can we try number 2? You want to try it on your own? You can pause the video, try it, and come on right back. But for number 2, again, you want to find the formula for the nth term of this geometric sequence. Good luck. All right, I'm going to figure out what my ratio is from term to term. Here it's a little bit tougher. It looks like, let's see, this is 3 over 1, 9 over 2, and I put 3 over 1 because maybe I can see what I'm multiplying by from term to term. It looks like on the top, I'm multiplying each top by 3, okay, and the bottom, looks like I'm multiplying by 1 to 2 to 4, maybe 2. Ah, that makes sense. Okay, so my ratio will be 3 over 2. Here we go, folks. A sub n formula would be a sub 1, which is my 3, and my ratio would be 3 over 2 raised to the n minus 1 power. I use a lot of extra parentheses here, but if you want to write it like this, with just the 3 in the front like that, that's absolutely fine. Both answers are totally legit. And again, we're finding the formula, so we leave the n in there. And there's your introduction to a geometric sequence. What we did in arithmetic sequences is we played with sort of these SAT shortcuts, where if I give you different pieces of the puzzle, can you go back and find other pieces like the first term, or the art ratio, or just the formula for the entire sequence. But we're not going to do that this year just because of the sake of time. But coming up in the near future, we will talk about geometric series, or how we add them. Now the cool thing is, when we did series before, we did it for an arithmetic one, but it had to be finite because it had to stop. But we're going to learn next time, exciting, exciting, you can actually find one if it's an infinite geometric series. We can actually add an infinite series of terms together. It'll be really exciting. Tune in next time.